Hello everyone and welcome to Genesis Customer Care tutorial. Today we have Dwayne Woman from Telephony Support Group presenting SIP call flow troubleshooting. And also we have Chris McLeod from the same Telephony Support Group with us to answer your chat questions during the session. There are a few logistics you should know before we get started. The session will be recorded and posted to the tutorial page of the Customer Care website in a week. You will receive an email with the recording link when it's available. Phone lines will be muted until Q&A session at the end of the presentation. If you need clarification about the material during the session, you can type your question into the chat window and Chris will answer those questions, unless it would be better answered during the Q&A session at the end. When you exit the webinar, a brief survey will be displayed in your web browser. Thank you for taking a minute to complete the survey. Genesis uses feedback to improve our tech tutorials. And now I'm turning the session over to Dwayne.
I'd like to welcome everybody to this SIP call flow troubleshooting tech tutorial. A brief description, I guess, of the tech tutorial is it will be a review of the SIP and T-LIB messaging for different call flow scenarios, including several different call flows with issues and also ones that are good, and how to troubleshoot them appropriately. So there are so many different call flows that are possible, and so it was impossible to cover them all. But I hope this tutorial gives you guys at least a technique or a method for tracing these call flows within the SIP server logging. The tech tutorial will focus mainly on the review of the logs itself, and we won't be relying solely on the slides of the presentation, since it is a call flow analysis. So we first start with the tutorial topics. So the tech tutorial first will be an introduction to the tools that will be seen during the tech tutorial. The next thing we focus on is the actual call flow analysis, and there are several call flow examples that are listed here that we will be going through. So let's start right in. The tool introductions where we begin. The tools that will be seen today, these are the ones that I use during my analysis. There's also other ones that are listed as well. Obviously not limited to these particular tools. There's other ones out there that people use. The ones that I use on a daily basis include Casimir, which itself is a visual Genesis T-LIB call flow plotter showing T-LIB messaging only. TextPad, or in reality any advanced text editor, can be used. I use TextPad. SIP log visualizer, which provides a graphical representation of the SIP server log, not only for SIP messaging but also for T-LIB as well. There are other tools out there, not going to be covering during this tech tutorial, including SIP span, Notepad++. There are other ones as well, just not covered. You know, outside of TextPad and Notepad++ and all of these third-party text editors, the other tools, Casimir, SIP log visualizer, SIP span, all the ones developed by Genesis can be found using the knowledge base search or software downloads on the Customer Care website. So let's start right into it, call flow analysis. So in this case, we're going to start with the first example. The first example is a good call for an inbound call coming in through ISCC, arriving successfully at an agent's DN. So this will be a very simple call. It'll get us started on what we're looking for when it comes to the SIP messaging. So I'm going to show these examples in 3 different formats. I'm going to start off by showing them in Casimir to show you what it looks like in Casimir. Then we're going to look at it with a text editor. In this case, it's going to be WordPad because I did some editing on the actual log. And then we're going to finish with SIP log visualizer. So we'll look at the call flow in SIP log visualizer. So just give me a sec. I will pull up Casimir. So here is this simple call flow from Casimir's standpoint. We see an inbound call, ICC call coming into ERP 8,888 and landing on agent DN 5,000. So pretty simple. We need to turn on the ICC messaging as well. So now it's listed here. So we're now going to move on to looking at it directly from a text editor. So in this case, I'm pulling up the output within WordPad. So what I've done actually in these examples is I've actually grayed out the areas, the particular messaging I don't feel for this particular analysis is important. These grayed out areas will not be focused on. Obviously, this is for this particular example. These grayed out areas may be important in other examples down the road, but obviously I'm focusing on the ones that are actually highlighted. So let's go through this case now. So this particular call example, we start in with an ISCC request being received by SIP server. So it's being received by another T server, in this case T server UCM 8.1. In this case, SIP server takes this message. It's an ISCC request get call data transfer service message. It then must provide some form of access code to get the call to SIP server. In this case, an access code of 8888 is sent in response. The response is sent in an ISCC event call data transfer service message back to the T server UCM. So in this case, SIP server is now waiting on the call to arrive. And in this case, you'll see the invite message arriving from the Cisco trunk. In this case, that is the trunk label at this point. I have also highlighted the call IDs, as we will be dealing with multiple call IDs. So I've highlighted them in different colors so you can actually keep track of the call legs for each individual party involved. So in this case, this one is labeled red for the inbound call leg from Cisco. So I also focus, when I'm doing my analysis, not everybody's the same, but I focus my analysis on the SIP server processing within the logging. So I usually focus on the steps that SIP server is doing in relation to the actual call. You'll see these listed out, and they're actually highlighted. So we begin with the first step, which is the create call step. This is actually placing the call in SIP server's memory. So it's a very quick step. You'll see here that it gets started and then completes. The next step in this case is SIP server is looking to see whether a dial plan is used and whether a rule matches the destination. In this case, the destination is 8,888. No rule is applied, so the dial plan does not get used. SIP server then creates a new con ID for this particular call. You'll see we'll continue on. You'll see how the step numbers go as well. They'll increase until the end of the SIP scenario. So the dial plan step is now complete, and we move on to the change party state, which completes very quickly because we're not changing the state at this point. The get offer step also starts and completes very quickly because the invite already has the STP information in it for the offer. The next step, which is the most important step at this point, is the connect new parties step. So that begins. Since the call is being sent through an ERP, what the SIP server needs to do then is generate an event queued with a new con ID, as we've seen above. This event queued will be generated on the ERP number. You see here, 8,888. SIP server does know then that this is an ISCC related call, so it must change the con ID to the one that was received in the original ISCC request, which in this case is that number right there. So we continue on. Due to this ISCC being engaged, SIP server must ISCC adjust the event queued, and it does that, as you see here, adjust the event queued. At this point, you may see a bunch of user data that was present in the original ISCC request. My particular call example didn't have any user data, so it's not listed. The next part of the call, obviously, is the event route request being generated on the ERP as well. SIP server then must send back a notification to the Cisco trunk, in this case in the form of a 180 ringing. So it's sent to Cisco, and then we complete the connect new party step. At this point, the SIP scenario is completed as we're now waiting on the actual route to occur to the actual agent. So the next part of this is the dequeuing of the request route call. The ICC request route call request is dequeued and is then generated. You'll see here that the destination is actually the agent DN5000, so that's the agent that is targeted from the other T server. You'll see here that, again, since the destination is now changed from 8,888, it's changed to the destination of 5,000, that we must use check the dial plan again. So the dial plan step is started, but it does not match any dial plan rules that are in place. So the dial plan step completes, and then we must start a transfer call step. So in this case here, this is where we would then send the invite out to the agent 5000 SIP endpoint IP address. So you'll see here, you'll see the invite being sent out to this agent's SIP endpoint's IP address. You'll see here that the call ID that I've labeled in blue is a different call ID, as it's a different call leg. The red's for the inbound call leg from Cisco, and this one is the leg going out to the agent SIP endpoint. Moving on, in this case, we receive back a 180 ringing from the agent SIP endpoint. Continuing on, due to that 180 ringing being generated, the SIP server then generates an event route used. This is the initial. We also generate an event diverted as well. These are all being generated on that ERP as you see here. SIP server then must forward that 180 ringing that it received from the agent SIP endpoint and forward it out to the Cisco for the original call leg. Continuing on, due to the 180 ringing that it received from the agent SIP endpoint, SIP server must generate an event ringing. In this case, you can see here this DN is 5,000, that's the agent DN. Now, because there's no client registered for the DN 5000, this message is not sent to any clients. So the transfer call step is now complete, and you can see here at this point the SIP scenario is complete because now we're waiting on, SIP server is now waiting on the call to be established, so for the agent to pick up the call. At this point, due to this scenario being completed and us receiving back a 180 ringing, the SIP server then sends an ISCC event call data transfer succeeded to the T server UCM 8.1. So it does send it on. The next thing you see here is SIP server receives a 200 OK. So this is the actual answer response that we're going to see from the agent endpoint. So again, note the blue call ID that matches the call leg going to the agent endpoint. So you see here, this is the 200 OK answer response. In this case, it has all the STP offer, all the codecs that it is capable of. SIP server begins a new connect complete answer step. And then SIP server forwards that 200 OK, as you can see here, on the original call leg out to Cisco with the new STP offer. Continuing on, SIP server receives back from Cisco an ACK with the PCMU codec that's chosen for the call leg. SIP server then must generate this ACK and send it to the agent SIP endpoint. Again, you'll see the blue call ID. This is for the agent endpoint. And you can see here that the codec is chosen as PCMU. At this point, the agent is established with the call, so SIP server must generate an event off hook for this DN 5000 and an event established for this DN 5000. So at this point, the caller and the agent are talking. Everything is good to go. They're speaking to each other. SIP server then completes the connecting complete answer step, and the SIP scenario is now complete. So Obviously, this was only about 54 seconds later, but in some logs, some larger customer logs, this by may be further down within the log, maybe harder to find. Obviously, you're going to look for the call ID. So this by comes in this case, from the agent SIP endpoint. So the actual agent was the one that released the call in this case. So we get this by from the agent SIP endpoint. SIP server then must send out a 200 OK for the by, notifying it that it understands that it received a release notification. SIP server then generates an event released for DN5000 and an event on hook for DN5000. SIP server then forwards the by that it received out to the Cisco for the original call leg. SIP server also sends an ISCC event called deleted to the original T server, UCM8.1. The con ID for the call is tore down, as you can see here, destructed. And at this point, all we receive now is the 200 OK for the by that was received or that was sent to Cisco. So that's the end of that call example. What I'm going to do now is I'm going to actually pull it up in SIP Log Visualizer so you guys can see what it looks like in SIP Log Visualizer. So you can see here that, and I'm not sure how many people here on the call today are actually familiar with SIP Log Visualizer, but it gives you a representation of the call from a T-LIB and a SIP perspective. You know, as long as you know the IP addresses and everything, you should know where things are going. Kind of gives you a very nice view of what the call flow looks like. So again, exactly what we reviewed: invite, by. You'll see all the T-LIB messaging here. Everything looks good. So that's another way to do your analysis as well. Obviously, we don't fully rely on the SIP Log Visualizer. We also rely on reviewing the log, but it is a good you know, thing to have beside you as you're doing your review. Okay. So, you know, if there's any questions on that particular example, please feel free to write into the actual chat window, or, you know, feel free to ask it, make note of it, and ask it at the end of the session. So let's move on to example number 2. In this particular example, it's another good example where for an agent who dials to a route point, and then this call is then routed to another location using ISCC. So another simple call, just going through the basics of an inbound and outbound call. We're first going to look at this again in Casimir. So you'll see here the request make call in this case is coming from a soft phone, hitting a route point of 11,111. Treatment is applied, is then routed externally to T-Server UCM8.1, and call ends. So let's just get right into it. We'll go through it with the text editor, and we'll go through step by step. Okay, again, similar to the last one, I've graded areas I don't feel are important for the log analysis. So let's get right into it. And the first thing we look at here is the request make call coming in from the agent's soft phone. You'll see here the agent DN is 5,000 once again. The dialed number is 11,111. That is the route point number. So since it's a dialed number, SIP server must look to see whether there's a dial plan in place. So there's a dial plan step that begins. It notices that there's no rule set up for this particular destination, and so the call continues on and is forwarded to 11,111. SIP server then must generate a new call con ID, so you'll see the new con ID get created here. The dial plan step is completed, and SIP server then starts a make call step. So in this case, because this request came from a soft phone, it's considered a third-party call control request. So the first person that needs to be engaged into the call is the actual agent's endpoint itself. You know, so you need to actually send a call to the agent SIP endpoint in order to get them engaged in the call first. So here's the invite going out to the agent SIP endpoint. You'll note here the red call ID, that's for the original agent SIP endpoint's call log. You'll see next the event off hook is then generated for the agent's DN. Also an event dialing is generated. In this case, you'll see the event dialing and the event off hook being sent to the softphone client. At this point, SIP server then receives back a 180 ringing from the agent SIP endpoint. SIP server then waits for the answer response, which is received in the form of a 200 OK. SIP server receives this answer response from the agent SIP endpoint, again noting the call ID. SIP server responds with an ACK for the agent SIP endpoint. At this point, since I have refer set up for this particular call example, so refer enabled equals true, SIP server then sends a refer to the agent SIP endpoint, asking it to perform the transfer, and you'll see here the refer to has the route point DN number. SIP server then receives back a 202 accepted from the agent SIP endpoint, stating that it's able to do this particular function. SIP server receives back a notify message from the agent SIP endpoint with a status of 100 trying. SIP server, as you can see here, sends an actual 200 OK to the notify message, and I'm kind of bolding out these C sequence numbers. I wanted to point these out. These C sequence number will be unique to every one that's being sent out as a notify, as a cancel, as an invite. This will accumulate, this number will accumulate. So to match up the 200 OK with the notify, you'll see here that the C sequence number will be identical to the original notify, and it will be labeled with notify as a tab as well. So it's listed there, so that's how you match these two up. Obviously the call ID is also the same, but that gives you an idea of how to match up these two particular SIP messages. SIP server then, due to it being a refer leg, SIP server then receives a new invite with a new call ID. As you can see here, this new call ID in blue with the STP offer from the agent SIP endpoint. This will be the agent SIP endpoint. This will be the new call leg for the agent SIP endpoint. The original call leg in this case, as you can see in red, this was the original call leg that came in that was sent out to the agent SIP endpoint, is ended as it's no longer needed. The original call leg didn't have any STP set up. There was no active dialogue. It was just one that started the transaction. So it's canceled with a buy. The make call step, as we've seen previously, is now completed. The get offer step starts and completes because we already have the STP offer in the invite that was received from the agent SIP endpoint. And the connect new party step begins. So now we're actually connecting in the new party, which is the route point. In this case now, because the call is going to a route point, we must generate, SIP server must generate an event queued and an event route request. And in this case, these two messages are sent to URS. SIP server then sends a 180 ringing to the agent SIP endpoint, letting it know that the call is proceeding. You'll see here that the new call ID now in blue is the one that we're using for the call leg with the agent SIP endpoint. The connect to new party step completes. And at this point, the SIP scenario is completed until we get further information from the URS on the call. You'll see here the C sequence number for the buy. This was the buy that was sent from SIP server to the original call leg for the agent SIP endpoint. You see here listed in red. So that is the 200 OK for that buy. At this point, the strategy, obviously on the route point, progresses and determines that an announcement needs to be provided to this particular caller. So you'll see a request applied treatment for coming in from URS with a play announcement. So at this point, subserver must locate a VoIP service DN to handle this particular request. In this case, it finds a VoIP service DN of type labeled as treatment. SIP server then starts a connect media service step as well, and it then sends an invite to a media server that is associated with that treatment VoIP service DN. In this case, for this particular example, I'm using Stream Manager. At that point, so we have all the information for the actual announcement being sent to Stream Manager. At this point, Stream Manager then replies with a 200 OK. You'll see here the codec that's being offered is PCMU. SIP server forwards this 200 OKs. You can see the blue call IDs for the agent leg. It sends this to the agent SIP endpoint with the codec offer of PCMU. At this point, SIP server then knows that the treatment is starting. So event treatment applied has been generated and is sent to URS, letting it know that it's successful. The agent SIP endpoint acknowledges the STP offer, and this acknowledgement is forwarded on to Stream Manager. And the connect media service step is now completed. So you'll see here now that the SIP scenario is now completed. So now we're waiting for the ending of the announcement and the next routing instructions. So now at this point, the announcement's being played to the agent who called the route point. So you can see here, it's only a couple of seconds. The announcement is. You'll then see a buy coming in from Stream Manager, stating that the treatment is now, in this case, the announcement is now ended. SIP server responds to the buy with a 200 OK. Event treatment end is now generated by SIP server and sent to URS, letting it know that it can continue on with its strategy. The detach media service step that then begins. So this is just clearing up the actual information out of SIP server's memory with regards to the media service. It ends, and then at this point, the URS continues on with the strategy. So at this point, we get an update user data, which you can see here. It's successful. We won't focus on that. The next part of this is the actual target block, which is the route going out to a destination, which is 3018 at the Cisco UCM location. So at this point, SIP server knows that this is a location that requires ISCC. The attribute location really tells SIP server that it must use ISCC in this case. And so SIP server sends out an ISCC request get call data transfer service out to the T server UCM 8.1. In this case, the Cisco UCM T server sends back an access code of 3,333 in response. So this is the number that SIP server must dial or route in order to get to the actual Cisco T server. You'll see now that SIP server populates an ISCC request route call. You see the destination now is 3,333, so that gets generated. And at this point, SIP server must determine whether this number is internal or external, and at this point it is non-internal. So it must route the call externally, which makes sense in this case. You'll see a trunk, Cisco_trunk, gets selected for this particular request. The transfer call step begins, and at this point, you'll see the invite being sent out to Cisco with a destination of 3,333. And you'll see here that I placed this call ID in purple, just as it's a different call leg. SIP server receives back a 100 trying from the Cisco in this case, and then also a 180 ringing. Due to the 180 ringing, SIP server generates an event route used. It also adjusts the event route used as well, which is a normal process. The ICC adjusted event route used is then sent to URS. SIP server also generates an event diverted from the route point DN, which is sent to URS. And also an event network reached is actually sent, is generated on the agent DN 5000 and is sent to the soft phone as well. At this point, we complete the transfer call step as we have received a 180 ringing from the Cisco. We also generate an ICC event called data transfer succeeded. We send that to the T-server UCM 8.1. Or actually that is received, sorry, I do apologize for that. It's actually received from the T-server UCM 8.1, stating that it received it. We generate an event remote connection success due to that message and send it on to URS. At this point, SIP server is now waiting for the Cisco to provide any further feedback on the call. And at this point, we receive a 183 session progress from the Cisco UCM. It does have its codec offer of G729, PCMA, PCMU. These are the 3 different codecs it offers. We then get a 200 OK with the same codec offer from the Cisco as well. So this is an answer response in a way. The connect complete answer step begins. We must send the offer to the agent SIP endpoint. So you'll see here the blue call ID is shown here. So we send the offer with the 3 different codecs that are available to the agent SIP endpoint. We then wait for the agent SIP endpoint to reply to this offer. You'll see here that the agent SIP endpoint replies with a 200 OK. At this point, it's confirming PCMU. It doesn't show it listed there, but it is. SIP server sends this, forwards this ACK out to the Cisco. And at this point, SIP server generates an event established. This event established is generated on the agent DN and is forwarded out to their soft phone. SIP server then sends an ACK out to the agent SIP endpoint for the 200 OK that was received. The connect complete answer step is completed. So at this point, everything should be good to go. The one thing that we do see here, because the offer was with multiple codecs, the way that Cisco works is that it's going to reconfirm the exact codec that it wants to use. So in this case, the invite comes in, which is considered a re-invite, as it's another invite with an already existing leg. So this is a re-invite coming in from Cisco with the selected PCMU as the codec choice. In this case, we validate the STP state. We see that the offer is received. We also must generate a connect pair step. So in this case, we're going to send this re-invite out to the actual agent SIP endpoint, this time with the PCMU as the selected STP offer. We also then receive a 200 OK for that agent SIP endpoint, confirming the PCMU as the option. You'll see that we also then send out, in this case, a 200 OK. That same 200 OK is forwarded out to Cisco as well. You'll then expect to receive an ACK. We do receive an ACK from the Cisco in this case, acknowledging that the call is in progress. An ACK is then sent to the agent SIP endpoint. At this point, the connect pair step is complete, and the SIP scenario at this point has been completed. So at this point, the agent and the caller in the other location, the destination in the other location, 301A is now speaking to each other and talking. So sometime later, in this case, it's only about 29 seconds later, or sorry, 19 seconds later, we see a buy. So in this case, similar to last time, the agent SIP endpoint, so the originator of the call is the one who ends the call. So you'll see the blue call ID here. This is coming in from the agent SIP endpoint. So this is the buy that comes in. SIP server responds with a 200 OK, stating yes, we acknowledge that the call has ended. At this point, SIP server then must generate an event released on this agent's DN, 5000 you see here. Event on hook is also generated. Both of these messages are being sent to the soft phone that the agent is controlling. A buy is also sent, or this buy from previous is forwarded to the actual Cisco as well, letting them know that the call has been cleaned up. At this point, because SIP server is controlling the ICC transaction, it must send out the ICC event called deleted message to the Cisco T-server UCM 8.1. And then at this point, the last thing that is received is the ACK, the 200 OK in response to the buy that the SIP server sends to Cisco. So this is the end of the call scenario. So let's now take a look at it in the log visualizer. It's going to look slightly different than the last one, obviously, where there's more information going on. So you'll see here, make call, you'll see all of these listed, you'll see the numbers listed here, you see the queue is being generated on the route point, you see all this information for the T-LIB events, you'll see the invite, you'll see the refer, you'll see everything kind of what we already went through in a short form. So again, very useful to have sitting beside you as you're reviewing the log. So moving on, we're actually going to start getting into some failure scenarios. So those two were just kind of a warm up to show you guys what good calls would look like, and just kind of give you an idea of the analysis technique that I'm using. So in our third example, we get into the failure scenario where an agent's call to an external destination results in a fast busy being received by the agent, and also an event destination busy being generated. So let's take a look at this particular call within Casimir. Very short. So you'll see here it's a third-party call control request. So it's a make call request from the soft phone. You'll see here dialing and then event destination busy and release. So there was never established. So let's take a look at the call within a text editor. So within the text editor, again, this is going to be a somewhat short call review. So again, we see the make call request. It's a T-LIB request from the soft phone. It's considered a third-party call control request, same as before. Similar to the last call that we, the example number 2 that we reviewed, we're going to process a dial plan step. We're also going to validate that there's no rule assigned to this destination, which in this case is 8787. There is no rule applied, and so SIP server determines that this number is not internal. Due to it not being internal, it must look for a trunk service. In this case, test_trunk is the label of the trunk that it's going to use. So SIP server then creates a con ID for the call. You'll see here that as it's listed here, constructed. We're going to continue on. So the dial plan step is completed now, and the make call step begins. So in this case, similar to before, and I'm going to kind of browse through it. Because it's a third-party call control request, we must first engage the agent SIP endpoint. So that's what we're going to do. So we're going to send an invite out to the agent SIP endpoint. We're going to generate an event off hook and send it to the soft phone. We're going to generate a dialing, send it to the soft phone. We're going to receive back a 180 ringing from the agent SIP endpoint, and then a 200 OK answer response from the agent SIP endpoint. We're going to send out an ACK in response to that 200 OK. We then generate a refer message and send it out to the agent SIP endpoint as we're looking to transfer the call. Again, refer enabled equals true in this environment. The destination in this case, you see the refer to. The destination is 8787, so that's the number that's being dialed. 202 accepted is coming in from the agent SIP endpoint. We then receive a, similar to before, a notify with the status of 100 trying. SIP server sends back a response of 200 OK to the notify, and then a new invite with the destination of 8787 with a new call ID, as it's a new call leg, is being received from the agent SIP endpoint. This now has the STP offer similar to before, and so we're ending the original leg that did not have an STP offer, did not have an active dialogue. The make call step begins, completes after it began. We start a get offer request step, and it completes as we do have the STP for the invite above. We also do a connect new party step, so you'll see here that begins. So this is all similar to what we've seen in test example 2. We send an invite out, in this case, to this IP address. This IP address is the one that is listed within the contact option within the test trunk. So you'll see here this invite is now being sent out to that IP address. Destination 8787 is the number. You'll see the same STP offer that was received by the SIP endpoint. That's also being forwarded to this within this invite. So this buy message was previous. It was cleaning up the original call leg from the agent SIP endpoint. So we're sending out, SIP server is receiving back a 200 OK for the buy that it sent. In this case, due to the invite that we sent out on the trunk, we send back a 100 trying to the agent SIP endpoint. So this is letting the agent SIP endpoint know that the call is in progress at this point. At this point, we have not received a reply back to this original invite. So you'll see here 1344.553, 1345.053. So within 500 milliseconds, we haven't received back an answer to the invite message. So either a 100 trying, 180 ringing, or 200 OK. We've not received any particular messaging on this particular call. So we continue to send out the invite over and over again without getting responses. You'll see here invite, 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 and you'll see the times as they increase. They're increasing 500 milliseconds, 1 second, 2 second, 4 second, 8 seconds, 16 seconds, until we receive a timeout. So this timeout is controlled by, in this case, the SIP invite timeout that's listed in the SIP server options. So it's a 32-second timer by default. It times out, and so the call is looking to end at this point. SIP server will, at this point, look for another trunk to see whether one's available to use. And at this point, there is no other trunks available, and so the call must end. And it states no eligible service for this destination of 8787. At this point, the event destination busy is generated due to the timeout. So it is generated and is being sent back to the agent SIP endpoint. The next part of this is the new party, connect new party step that was originally started has been failed. So we actually failed the SIP scenario, see here. So at this point, the call has failed. What we would do at this point usually is generate and send a busy treatment, a fast busy treatment to the agent, letting them know they're getting a busy signal or a fast busy signal. So a busy is usually scheduled. You'll see here, apply fast busy tone. SIP server must look for a treatment service, a VoIP service DN. In this case, it's in the label of treatment. So it looks for that. and a media service step begins. SIP server, similar to before, sends the invite out to a media server. In this case, I'm using Stream Manager. 200 OK comes back from Stream Manager with PCMU codec. We then forward on that 200 OK with the STP offer, in this case PCMU, to the agent SIP endpoint. ACK is received from the agent SIP endpoint, and that ACK is forwarded out to the Stream Manager. At this point, the Connect Media Service is complete, and the agent is now hearing fast busy until the call is disconnected. So at this point, SIP server begins the transaction timeout step, and it completes it because it is to do with the timeout, which has already been completed. The reject call step then begins, and at this point, we're cleaning up the call. So SIP server is cleaning up the call. The buy message is being sent out to the agent SIP endpoint to end the call on that side. You'll see here the blue call ID. The reject call step is completed, so a clear party step begins, which cleans up the call from Stream Manager's side as well. So you'll see the buy being sent to the Stream Manager. The clear party step is complete. A new clear party step begins just to generate the actual T-LIB messaging. You'll see here the event released is being generated on the agent DN5000 and being sent to the soft phone, and an on-hook is also being generated and sent to the agent DN. The new call clear party step completes, and the SIP scenario is now completed. Even though it's in failure, that part of it to clean up the call is now complete. SIP server then must tear down the con ID, and it's going to start receiving back the 200 OKs that for the buys that it sent. So in this case, there's a 200 OK for the buy that was sent to the Stream Manager. You'll see here the buy, 200 OK for the buy that was sent to the agent SIP endpoint. So at this point, the call has failed and the call is ended. So let's take a look at this call within SIP Log Visualizer. So like what we've already seen, the make call step, we see the invite going out, we see the refer. You can kind of see here where kind of really you can focus on the area where we're sending out the invites to this particular IP address, and it's not receiving back any type of response. And then we see the leg going out to Stream Manager for the busy treatment. At this point, the call is ended. So it's pretty nice to see it within a visual diagram with SIP Log Visualizer. So moving on from here, since this was a failure scenario in this case, we're actually going to look at what the root cause was and what the solution was in this case. So in this case, the root cause of the issue was the fact that the test trunk was configured with an incorrect IP address. So the invite was being sent out to the trunk, but in this case, the IP address was incorrect. So within that contact option, within the test underscore trunk, within the configuration, the IP address was incorrect. So that was modified to include the correct IP address. So that was the resolution. So let's move on to call example 4, just trying to get through the ones that I have available. Call example 4 is another failure scenario, a little more complex. Inbound call coming in through IVR, GVP, and is transferred to a route point. Then the route point does an ICC route to a target in another location, but this call actually ends in failure. So we're going to look at why this occurs. So now let's first look at the call from a Casimir standpoint. So you'll see here, T-LIB messaging event, ringing established. You'll see call leaving the IVR port being transferred to an actual route point then doing an ISCC request, and for some reason it ending in failure. So let's get right into the log. Let's take a look and see what's going on with this call. So in this case, it's a little different than the last one. An invite is received from, in this case, SBC trunk. You'll see here that it determines that based on the IP address and what's in the configuration within the switch within SIP server. So you'll see this is the inbound invite coming in. You'll see call ID is in red for that call, for that inbound call. It also has the STP offer as well. SIP server determines that there's no calls in its memory that match this particular call, and so it must create the call. So you'll see it's creating it in its memory with the create call step. That create call step completes. It also looks at whether a dial plan can be used for this destination. There is no rule set up that matches this particular destination. And so SIP server then must create the con ID. The dial plan step completes in this case. Change party state starts, completes. The get offer starts and completes because it does have an offer of STP already. So that is very quick. Connect new party step, again, is the most important in this case, and that's where we begin. So at this point, SIP server knows that this call is going to an actual destination in GVP, so it must send an invite to GVP in this case. So you'll see here the green is a new caller leg going to the GVP service. GVP responds with a 100 trying in this case, and this 100 trying is then forwarded out to that SBC trunk. Event ringing is generated on this DN. You'll see here a little further down. You'll see here 180 ringing is received from GVP, and this is forwarded out to the SBC trunk. At this point, SIP server must generate an event ringing on this particular DN, which is an IVR port. The connect new party step is completed, and the SIP scenario at this point is completed just for the simple fact is we're waiting for something to happen from GVP. At this point, we receive a 200 OK from GVP with the STP offer. You'll see here the green call ID, that's from GVP. A connect complete answer, which is, this is the answer response. Connect complete answer step begins. We forward out this 200 OK answer response with the actual codec offers to the original caller through the SBC trunk. SIP server generates an event established on that IVR port, and then SIP server receives an ACK from the SBC trunk on the inbound call leg and forwards it to GVP in this case. The connect complete answer step is complete, and the SIP scenario is complete until we receive further instruction. At this point, GVP wants to confirm the exact codec, or actually it's not GVP, it's the actual SBC trunk, wants to confirm the exact codec that's going to be used for the call. In this case, it's PCMU is selected. So it receives that re-invite on the already existing dialog. So SIP server determines that this is a new STP offer with a selected PCMU, so it must generate a connect pair step. You'll see a re-invite being sent out to GVP with that PCMU codec selected. 100 trying is received from the GVP. 200 OK is also received from GVP, confirming PCMU is the codec. So we must forward out that 200 OK to the original call leg SBC trunk. ACK is received from the SBC trunk to acknowledge the call, and ACK is then sent to GVP. At this point, the connect pair step is completed. And the SIP scenario is completed at this time as well. So at this point, the call is on GVP. It's on the IVR. the call is progressing in that area. So now we're waiting for what the next step is from GVP. So we'll go down through the logs a little bit, and it is going to take a few seconds. So the first thing we receive from GVP is the fact that we're receiving an info message, and that info message contains some attached data. So you see down here some attached data. So in this case, SIP server must generate an event attached data changed, and some other messaging event called data changed. It must generate these and send it to the clients that are involved. At this point now, SIP server must respond with a 200 OK for the info. You'll see here the CC1 with info. SIP server must send a 200 OK with that particular info message. A little later on, in this case, it's only 3 seconds later, but it could be minutes later. SIP server receives a refer message, which in this case would be translated as a transfer request from GVP. You'll see here the green call ID. The destination in this case, you'll see here in the refer to, is 0011223344. So that actually translates to a row point. So in this case, SIP server sends back a 202 accepted because it does understand that it needs to transfer the call to a row point. It needs to check to see if the number dialed or the number used needs to be changed through rules. So the dial plan rule is checked, nothing is used, so we continue on. Dial plan step completes, and so we're into the transfer call step at this point. You'll see here that SIP server now releases the call from the IVR port. See here, this DN, that's the IVR port DN, and sends it to its clients. A little further down. So SIP server knows that this needs to go to a row point. So similar to before, we're going to generate an event queued, send it to some clients, especially URS, event route request, again, sending it to its clients, and also in URS as well. So at this point, the call is on the row point. The transfer call step is now complete. We're executing the CTI request just with the 200 OK for the GVP leg, letting it know that it's completed, no longer needed. At this point, the strategy on this, loaded on this row point, URS sends update user data, so that contains some characters. Regenerate event attached data change, which is normal. Send it out to the URS clients. Event call data changed for the reporting clients. At this point now, a target's being chosen. So within the strategy, we have a target block, and it's being decided to go to a location via switch. So the destination is 5552222. So this would be the destination. So in this case, similar to before, SIP server knows that this is for a location that requires ICC per the attribute location field, and so ICC must be engaged. So you'll see SIP server generate an ICC request get called data transfer service. This gets sent out to the T server of Avaya. We receive back an ICC event called data transfer service with the access code. So you'll see the access code listed here from the T server of Avaya. In this case, SIP server generates an ICC request row call with that new destination. SIP server must, again, well, in this case, we're receiving the 200 OK for the notify from GVP, cleaning up that leg. The execute CTI request is now completed, and we're clearing the party. So in this case, we're actually going to clear up. We're going to send a bye to the GVP server to let them know that it's no longer needed. So bye is being sent, and the clear party step is actually completed. At this point, we're getting into the call is actually being sent to Avaya. So SIP server determines that the number dialed is not an internal number. This ERP is not internal. So it must find a service, a trunk for it. In this case, trunk labeled SBC trunk is used. Transfer call step begins. You'll see down here. and the invite is then sent to the IP address listed in the contact option of that trunk. A little confusion here. GVP responds with a buy on the original request that GVP holds. SIP server had already sent a buy, so it sends back a 481 call leg transaction does not exist. This is fine. It's normal. Sometimes there is a little bit of a race condition where GVP is cleaning it up at the same time SIP server is, so that's not an issue. It doesn't cause any issues. At this point, on the original invite being sent out to the Avaya, you'll see a trying coming back. So in blue, you'll see the call ID there. At this point now, GVP realizes that yes, I did receive a buy on this, so it does send out a 200 OK to SIP server, and SIP server receives that. Going down a little further, so we're looking for hopefully a 200 OK response, a success response, but in this case, as this is a failure, the Avaya switch actually responds with a 408. Well, in this case, it's not the Avaya switch. It is the SBC trunk responds with a 408 request timeout. At this point, SIP server can only send an ACK at this point, and at this point, it needs to generate an event error with a no answer at DN. Due to the fact that the call was not successful, SIP server also has to send an ISCC request cancel call data transfer service to the T server Avaya. The transfer call step fails in this case, and you'll see the SIP scenario fails in this case as well for this particular scenario. Another event error with no answer at DN is dequeued and is sent to URS, as you can see here, to its client. So it knows now, URS knows that that particular request within the strategy failed, so it must continue on. In this case, the strategy is built to have this type of failure in place. So it continues on. The request updates some user data. We see that being generated. That's fine. The next thing we see is another target. So at this point, we're seeing a target that's local to SIP server based on the location and based on the other DN. That is a local DN. Not local to SIP server, but not on an actual, not an Avaya, obviously. So at this point, that number is determined, but SIP server does realize that this number is not an internal number to itself. It knows that it's an external number that needs to be sent outside of SIP. So again, it must look for a trunk service. In this case, it finds the same SBC trunk as used previously. So SIP server then, again, similar to before, must start a transfer call step. In this case, I've labeled, as this is a new call leg again, I've labeled it in orange, and here's the invite being sent out to this SBC trunk for the destination, this new destination. In this particular scenario, we're not successful. So we get back a trying from the SBC trunk, but we're also not successful in this case as well, unfortunately. And so we get back a 500 server internal error, destination unreachable. So for whatever reason, the actual destination is not available. SIP server then, at this point, can only send back an ACK on this response, and at this point, has to generate a DN is busy with event error, sending it to URS again. So once again, URS has to determine what it wants to do with the call next. This transfer call step fails. The SIP scenario has failed. At this point, within the strategy, there's another update, user data, in this case, peg rejected 1. That's sent to its clients. You'll see it's sent to reporting server, or to reporting is what I meant. At this point, we actually generate, or we see a request row call from URS. In this case, it's with a blank destination, so with a row type reject. So it's trying to clean up the call, try to forward it out to its default destination. But unfortunately, with this call, there was no default destination within this particular call. And so at this point, SIP server has no option to transfer the call anywhere. All it has to do is to clean up the call. So you'll see reject call step begins. Buy is then sent out on that original leg to the SBC trunk. This is for that inbound leg way back in the call. Reject call step completes. Clear party step begins. At this point, event route used and event diverted are coming in and being generated on that route point and being sent to URS. Clear party step completes. A new clear party step begins to clean up the call party. See here, call party deleted is generated, sent to icon. That clear party step completes. The call ID is destructed. It's tore down. And at this point, SIP server then receives back a 200 OK from the original call party. And at this point, we haven't connected any other parties, so this is the only one that needs to be cleaned up. So that's the end of the call. So let's take a look at this particular call within SIP log visualizer, and we'll just see what it looks like. It's pretty marginal here. There's quite a bit of different things. These event resource info that's coming in from GVP all are being generated due to GVP being involved. So you'll see here a little bit harder to follow, but you know the high points, I guess, at this point is obviously the invite coming in for the new call. You know, you can stand out the info message coming in from GVP, the refer message coming in, but in reality, the ones that we're really focusing on at this point are the failures. So in this case, the 408 request timeout with the event errors, the 500 server internal error, destination reachable with the event error, and the call being cleaned up. So that's what we would see within SIP log visualizer. Since this is a failure scenario, we must look at why it failed. And unfortunately for this particular call scenario, the solution was somewhat vague. We do know that the root cause to this issue was the fact that SIP server was receiving a 408 request timeout from the SBC trunk, and also for the one going to Avaya, and also a 500 server internal error destination reachable for the second request going out to an external destination. What was found was there was an issue found on the SBC trunk side, a configuration issue, and that is about as much as we received back from feedback, was a configuration issue that was received, seen on the SBC trunk side that was resolved. So something to do with maybe an invalid number or an invalid pathway to Avaya or something that first call, why that first call failed. The second part of the call failed, obviously due to maybe another invalid number or something along those lines. So let's continue on. So call example 5 deals with not really a failure scenario, but kind of a scenario where a customer is looking to have a call handled a certain way, and it was not handled a certain way. So a call that comes into an agent where the agent's already on a call, where the actual customer would like to have the call rejected in that case. So let's take a quick look at it through Casimir. You'll see here, make call, you'll see the call flow. This is the original call that the agent is set up with. And you'll see this new call coming in that does not get answered. So we'll quickly go through this as we are kind of running out of time here. I do apologize. So let's look at this one really quickly. From a text editor standpoint, we're looking at this call, and again, I've kind of, the original call we're really not concerned over. We're really concerned about the new call that's coming in. So I've kind of grayed out the area of the call that was previously active. The one thing we should note at this point is that there is an established time, which is 9:50:40, and the fact that there is no release in between that and the new call. So the agent is still active on a call. So at this point, we look at the invite, the new invite coming in for this particular agent's DN, a new invite coming in, you'll see it in red. SIP server determines that this is a new call, does not match any particular calls that are in place already, and so create call step must begin. In this case, it needs to resolve to a dial plan. Is this number resulting to a dial plan? And it does resolve in this case to rule 8, but it does not change the digits that are dialed, just that if it's not registered option. So in this case, a new CON-ID is being created. You'll see here dial plan step completes, call party state begins, completes, get offer state step completes, as well as there is already an STP offer. We then connect the new party. In this case, we're going to send out the invite to the agent SIP endpoint, asking the agent SIP endpoint to answer. You'll see the call leg in blue this time. 180 ringing is being received from the agent SIP endpoint. We forward that 180 ringing back out to the inbound caller. At this point, SIP server must generate an event ringing on the agent's DN. You'll see it being sent to IWS. In this case, the agent's soft phone is IWS. The connect new party step is completed, and the SIP scenario is completed until it receives an answer response from the SIP endpoint. Looking down further, so this request release call is for the previous call the agent's on. So at this point, these are the messages we're seeing. The request release call and the event released are for the previous agent's call. You'll see here that the agent does not want to answer this call, so he does not accept the call, this new one that comes in. So you'll see here down here, eventually the inbound call leg, which is coming in, gets canceled. So after a timeout, the trunk decides to pull back the call, so it cancels the call in this case. So that's what we received from trunk 2. At this point, SIP server sends a 487 request terminated on the call leg, and 200 OK is being sent on the cancel. Cancel message is also sent to the agent's SIP endpoint to clean up the call. Event abandoned is generated on the agent's DN, being sent to IWS. On hooks being generated and sent as well. Event released is generated. In this case, with this DN SIP location, which represents the actual caller. Call is CON-ID is cleaned up, and the ACK is received for the original inbound caller, and 200 OK is received for the agent SIP endpoint for the cancel. Request terminated is received from the agent SIP endpoint, and the ACK is sent out for the agent SIP endpoint. So the call just never happens. So that's what this one's about. We're going to look at this one quickly within Log Visualizer. Again, running out of time. So we see very similar to what we've seen already. This is the original call at this point, all the way down to the established. This invite here is the one that we would look at as the new call coming in. So you'll see the ringing being generated, never an established. So the agent never answers the call. So what actually, since this was kind of a failure, not the way the customer wanted to do the particular scenario, what the root cause was they needed to have a feature enabled, which is reject calling call, which is a SIP server option that needs to be set on the agent's DN. In this case, it defaults to false. When they set the reject calling call on the agent's DN to true, it's not available in a SIP server application options, then the call is then rejected. So further details regarding this option can be seen within the SIP server deployment guide on page 170 in regards to the ring through rules. So we're going to quickly go to the next one. So this one actually is the result of what the customer set up in the last example. So the customer actually put on the ring through rules with reject calling call set to true, and this is what we're going to look at next, is how it looks when the call is rejected. Let's quickly look at it within Casimir. So at this point, this is the original call that the agent's on, and then we don't see another call being generated for the new call. So let's quickly look at it within text editor. You'll see here, as before, I grayed out the previous call. Here we note the established time of the previous call, 13:55:57. You'll see here that in between there is no release. So the agent is still on a call. At this point, we receive a new invite for the new call. And at this point, we receive it, and here is the call leg. It's in red. It's coming in from trunk E this time. No call matches in SIP server's memory, so it must generate a new call. Create call step begins, completes, dial plan. There is no dial plan matching this particular number that's dialed. In this case, you can see here this step right here. So the actual SIP server knows that because of reject call in call being set to true, SIP server knows that a call to this DN that's already on a call has been rejected. So it actually generates this messaging, a rejected notification, and then a busy message is being generated. So 603 decline is sent on the original call. In this case, reject call step is completed, SIP scenario is completed, and ACK is received from the trunk underscore E. So let's quickly look at this within SIP log visualizer. And this one's pretty simple. So this is the original call. The call is actually established. Here is the new invite here. 603 decline being sent out. So don't think I have enough time at this point to go through the next example, but it will be present within the notes of the actual tech tutorial, so you guys can review. I'll make sure that the notes are placed in there as well. This was just a treatment failure, so it was just a basic treatment failure. We can take a look at it. We won't go through the actual log analysis of it, but we can pull it up in Casimir and also in Log Visualizer, and I'll point out the high points of it. So just give me a sec. So this particular example was an inbound call to route point 8052, where a treatment was requested but not applied. So in this case here, let's take a look at it within SIP log visualizer really quickly. So you'll see the invite coming in, 8052. It's a route point, so it must generate an event queued event route request. SIP server sends back a 180 ringing. At this point, the strategy on the route point is progressing, so it knows that it needs to generate an apply treatment. In this case, the treatment is 101_mula.wave. SIP server sends the invite, in this case, MSML request to media server. 100 trying, 200 OK. We send the 200 OK back on the original call leg. ACKs are received, sent and received. In this case, we send out the info message with all the information on the treatment. It's a little different than the stream manager one that we looked at earlier. At this point, we get back at 200 OK, but in this case, the failure here is the fact that the media server is unable to find that treatment file. So in this case, we receive an external document, fetch error, failed to fetch file. So that's the failure notification, and then at that point, we continue on. So that is the end of the tech tutorial. That's all the information I wanted to provide. Again, the information regarding the example number 7 will be provided within the tech tutorial notes on the website once it's available. Important thing to note here, in this case, the treatment failure, sorry, I'll just go through quickly the root cause and resolution. The first treatment failed due to an incorrect name or location of the announcement file. There was a second failure where the MSML service was not enabled. One thing to note here, there are major differences between SIP server processing, I guess overall, SIP server event flow and T-LIB messaging between different SIP server versions. So the ones we focused on today all were from the 8.1.101 release. So it may look a little different depending on what release you're using. Other resources. So in relation to other resources here, I've noted a couple of other useful tech tutorials that relate to this SIP call flow troubleshooting tech tutorial. They are tech tutorial 76, multi-threading with SIP server, very useful information, and also tech tutorial number 81, troubleshooting SIP server issues. Again, very issue. Not getting into call flow analysis, but very useful information to be used as well. And below within this page, you can see the link on how to access the previously recorded tech tutorials. I also will mention that there are some really great GU troubleshooting workshops as well. There's ones listed here: CIM platform troubleshooting, SIP server troubleshooting workshop, which we offer now as well, which is a good one, and then GVP troubleshooting workshop as well. So the link below for the Genesis University website. Again, definitely recommend people take up GU on this training. Very good training information. There's also a lot of good information within Genesis knowledge base. We do this on a daily basis with our tickets, so there's a lot of information within the knowledge base. Contains product advisories, answers to specific technical questions, manuals, help files, release notes, release advisories, tech tutorial recordings and slides, again very useful, troubleshooting utilities and white papers, and also solutions as well to issues and problems we've had in the past. So again, noting that there's over 20,000 reference documents, and there's a link for the customer care knowledge base. So just to let everyone know, there is an upcoming tech tutorial starting June 11th. It is Genesis Pulse, a new generation of real-time reporting. So if you feel interested in or are interested in this particular tech tutorial, I would suggest registering as soon as possible. Okay, thank you, everybody. Oh yeah, and let's yeah, go right ahead, Kira. Sorry.
No, go ahead. Just a reminder, when you exit the webinar, a brief survey will be displayed in your web browser. Thank you for taking a minute to complete the survey. Genesis uses feedback to improve our tech tutorials. And now we can start our Q&A session. Please click on hand icon on the meeting screen and I will unmute your phone lines. Or you can type a question in the question chat window. Okay, there is a question from Hariharan Nagarayan. I will open the line.
Sure.
Okay, go ahead, sir.
Yeah, hi. Is there a way to troubleshoot if there are one-way voice path or no-way voice path issues?
Yeah, so in relation to, so at this point, I kind of wanted to mention that as well. In relation to dialogue issues with actual RTP streams, which is the audio leg of the call, SIP server is not involved in that particular area. It's just merely setting up the actual dialogue, so it's setting them all up. The actual RTP stream or the audio stream is actually between the 2 points. So if it's agent phone to agent phone, then the 2 agent endpoints are the ones that the RTP stream is in between. If it's an inbound caller coming in through a gateway and arriving at an agent's phone, then it's the RTP audio stream is between the gateway and the agent's phone. So in this case, the SIP server log won't contain any of that information. So unfortunately, when it comes to those types of situations, we recommend using like a network tracing tool. So usually we ask to have it placed on both on one on each side. So if there's a dialogue issue, like you said, with the audio path, then we would recommend having it one on each side, either a Wireshark trace or a network trace, you know, TCP dump if it's Unix, depending on what devices we're talking about. We want to have a network tracing set up so that we could see the SIP messaging, but also the most important things, which is the RTP packets that are being sent. So that's how you would troubleshoot a dialogue issue.
Okay, thank you very much.
Once again, if you would like to ask a question, please click on hand icon next to your name, and I will unmute you. Okay, we have question from Ashok Nanda. Go ahead.
Yeah. One question, during that session, you're telling whenever the new call comes in, for the new call, before creating a call ID, it's gonna check it out. That is the thing you told, right? Now, what basis it's gonna check before generating the call ID for the call? If it is existing one for the ISCC and all, know when one SIP server to other SIP server goes, and what basis it's gonna identify before generating the call ID?
Okay, so it looks at, I understand what you mean. So it actually looks at a lot of different things. So what happens is SIP server holds every call, I guess, every call that it knows about in its memory, right? So it knows about every single phone call that's in progress. If it relates to an ICC call, because of all the different, because of the incoming number, like all the numbers, the inbound number, all those numbers that are used, the DNS, the ANI, and all that stuff, it knows that if it may have a call in progress that matches the number that invite's for, right? So it knows that based on that or that contact, it knows that actual call may be for something else. So it knows that. So it looks at its memory first, and it goes through all the different areas of that invite and says, is there anything in there that matches any calls that I have in my memory? Mainly looking for ISCC type calls, but also looking for, calls that are in its memory. That's kind of what it does. I'm not sure if that answers your question or not, but that's kind of how it works.
Okay. And one more thing in the SIP server and ICC, same issues, I have come across, when I was trying to transfer the call from IVR SIP server to agent SIP server, because of the access code configuration, it was in the IACC, I was getting no answer at DN, the same thing. But I haven't make any changes in the trunk level. I've added the access code and the access code, then it started working. So what do you think, other scenarios to fail no answer at DN error message, other than the trunk IP configuration as per that scenario?
Yeah, it's tough to say for sure because I'd have to see the call scenario. I'd have to see it laid out the way I did in the actual tech tutorial. You'd have to look at, what are you receiving back in response? Like, are we sending an invite out to the other SIP server? Is it going through a load balancer? Like, there's a lot of pieces to this. So you'd have to look at, what kind of responses is it receiving back? Is it receiving back something that is failing? And why doesn't it like that particular number? That would be where I would focus on, I guess, if I was doing my analysis. If it was like a case that came in, I would start there, and then at that point, without knowing that, I guess, I can't generalize the event error, no answer, no answer at the end, because it could be caused by several different reasons, right? So.
Oh yeah, I understand that. Yeah, I was just trying to find out. Is there any common reason or No,
not really. I mean, it normally is because of a failure that when SIP server is trying to send the call to that other location, especially with ISCC being engaged, because it's sending out an invite to that other location, whether it's, like I said, to a load balancer or directly to another SIP server, there's some type of failure or something that it's not getting back in return that it needs in order to progress the call. So that's the reason why that no answer at DN is being generated. In that particular scenario, no answer at DN could be happening for many different reasons in different call scenarios as well. So.
Okay. Okay, thanks for that. Thanks.
No problem.
We have a question from line of Alex Locum.
Sure.
Go ahead.
Hi, this is Alex. Can you hear me?
Yeah, we can hear you.
Okay. There was a couple of the RCAs, the analysis on you were using Stream Manager, but in our environments, in the data environment, Stream Manager is going away, and we're using Media Server. But a lot of confusion with what is Media Server, and just to confirm one that the Media Server is the resource manager media control platform combination, or again, like I said, some folks think it's its own server application. Can you clarify that?
I definitely can clarify that. So I don't want to get into a lot of detail because it's we're getting to the end of it, but what I will say is that I was using Stream Manager for the examples. The last example I had, number 7, was an media server one, which I wish we could have really went through in detail, but we ran out of time. Media server, the actual term media server, what that means is SIP server accessing media server directly. That's a direct media server, SIP server to media server. When you talk about GVP, it's not called media server anymore. It's called Media Control Platform, MCP. And that's where you have SIP server with Resource Manager and MCP and all the other GVP components. So in relation to the term media server, that is SIP server's direct connection. Where GVP is not involved, it's just SIP server's direct connection from SIP server to media server. And there may be a Resource Manager in between as well, but it's a dumbed down version of, and it only allows treatments to occur. It's not something where GVP is involved.
Right, and I think the question is that when you look to, okay, say we're going to set that up, but there is no application quote called media server to install.
That's right. It is called Media Control Platform, but the terminology and how we use it, and it's in the training material. How we use it depends on how it's architectured. So again, media server as a term is used when SIP server is talking to Media Control Platform directly, whereas MCP as a term is when SIP server is referencing a whole suite of GVP components.
Thanks for that clarification. I think that was helpful.
Yeah, no problem.
Okay. We have a question from the line of Rick Ray. I'll go ahead.
Yes, can you hear me?
Yeah, we can hear you.
Yes.
Yes, I'd like to know if you're going to provide the actual logs that you showed, as well as any Wireshark traces that are available, so that we can see both the audio section of those scenarios.
Unfortunately, I didn't capture. That's actually a good suggestion. I never actually thought of capturing the Wireshark traces in that case. The only one I do have the logs, and I am going to provide them. So when everything gets placed up on the website within about a month or so, it's going to, or within a few weeks, I think, is how normally takes.
It's one week.
1 week, sorry.
About
yeah,
1 week.
I knew I was off. All the examples, the logs, and all of my notes for each individual example, all of that's going to be provided within that as well. Unfortunately, I won't have the network tracing, as I didn't have them available during all the calls that were run. Most of them were ones I had ran scenarios in my lab. There were a couple of ones that weren't from my lab, so I don't have the Wireshark traces. I do apologize.
Okay, thank you very much.
Yeah, no problem.
Okay, looks like we do not have any questions. Oh, actually, we do have another question from Alex Slack online. Go ahead.
Thanks. Hey, Dwayne, one quick question. I think one of the things that we're asked in the analysis is to try to recreate the issue. Mm-hmm. Is there any type of, when you guys get a issue or a problem that you approach you take to try to recreate the issue? And that could be for a lot of times, a drop call or, low volume on the calls, or we can't hear the other party on the other end of the call.
Mm-hmm. Yeah, it's a tough one. I know reproducing issue examples I've been here 7 years, and that's one of the hardest things for us to do here. A lot of times we don't have the exact setup that you guys do. We don't have the exact options. We don't have all the correct information. But the first thing I always start with is an analysis of the call to see what the call flow is like, to see what it's going through, what does the strategy doing. Try to get all aspects of the call to see what it's exactly doing. And then at that point, if it's something that I can reproduce or I can attempt to reproduce here, I try to set up my environment in a way. A lot of times I'll ask for the options or a startup log and go through that as well to be able to kind of match my environment to the customers. It's a tough answer though, because it's something you're trying to do is we're really trying to mirror your environment in a lab and trying to run the same kind of call scenario. So obviously, if you guys have a lab that's matching your production environment, it's much easier, but it's the same kind of situation. You'd want to look at what's happening in the call flow from this production environment and try to match your call example exactly to see, with the same SIP server version and everything, all the same strategy to try to get the exact result.
Okay,
but it is tough. I understand.
Yeah, and especially I think the second part of that is when you have an RTP stream, like to your point earlier, that you have to get some type of Wireshark, some type of voice trace in conjunction with that as well.
Yeah, no, I agree. Those are the toughest ones. I do agree with that.
All right, thank you.
Mm-hmm.
Okay, we have no question at this time, and I think Chris answered all chat questions. So I think we are done. So at this time, no more questions. Thank you, Dwayne, for sharing this information. Thank you, everyone, for attending, and we look forward to seeing you on next Genesis Customer Care tutorials. Have a great day, everybody.
Thanks, everybody.